Use the trapezium rule with two strips, each of width 4, to show that an approximate value of this integral here is 32 plus 16 root 5. It's the integral between 1 and 9 of 4 root x dx. Use a sketch graph to explain why the actual value of integral of 4 root x between 1 and 9 is greater than 32 plus 16 root 5. Use integration to find the exact value of the integral of 4 root x between 1 and 9 dx. So I've got the question here then. Let's use a trapezium rule with two strips of width 4 to find this value then. So let's paste in the trapezium rule then and have a look at it. So A, or part 1 is it? Part 1. Right, so we've got the integral between 1 and 9, haven't we? So let's put that in. 1 and 9. H is b minus a. 9 minus 1 is 8. So let's put that in. Now the number of strips is 2, wasn't it? So 8, b minus a was 8. Number of strips is 2. So h is 4, as was stated. So we can put 4 over 2 in here. So I'm just going to replace that by 2 then. And then we've got y0 plus, now there's 2 strips or 3 ordinates. So this will be y2, won't it? And this will just be y1. So we can get rid of it because it only goes up to y1 here. Like so. So we've got that then. And there's our formula in this case. Okay, so let's work that out then. So what have we got then? We've got x0, x1, x2, x0, x1, x2, x0 is 1, x1 is 5, of course add 4, and then 9, y0, y1 and y2. These are the y ordinates then. y0, 4 root x, isn't it? And x is 1, so it's 4 root 1, which is 4. y1, put 5 in, 4 root 5. And y2 is 4 root 9, isn't it? Which is 12. So let's put them in then. So it's 2 times this one plus this one, which is 16, 4 plus 12, plus 2 lots of y1, which is 8 root 5. So we end up with 32 plus 16 root 5, which is what we wanted. Okay, so let's have a look at that then in terms of the sketch. Why does this value, why is this the value of this integral greater than this value that we've got from the trapezium rule? Well, if we look at 4 root x, I'm just going to use a straight ruler here to get an axis and put that in there and there. And let's have a little look at 4 root x then. Between 1 and 9. So here's 1, here's 4, here's 9. And then we've got our, I'm going to do a dashed line because 4 root x will look like so. There we go. Now we can drop these verticals here, can't we? So let's do that then. We're drawing the trapeziums. So up to here, across to here, and down to here, and then over to this one. We come up here, then down to here. Okay, hopefully that's illustrated it well enough. I should have curved it a bit more here, perhaps up here, so that the curve would be a bit more suitable. Which I could do, but I'm not. I might do that actually, just to illustrate it a bit more clearly, because that's not terribly good. So if we curve it a bit more, so if I come out up above a bit, like so. Like that, that's a bit better, although this curve's not great. And now if we just find my ruler, and then I go up here, and hopefully I can show these sections a bit more clearly then. And this one over here. From here to here. Again, it's not perfect, so I would hope that with a non-digital pen you'd be able to draw a slightly better line than that sketch-wise, but it needs to illustrate these gaps here between these trapeziums, and this top of course is coincident here. Okay, so there's an area here, there, and in there. So the areas, so basically explain why this value of the integral is greater than this. Well, the area of the trapeziums, so here, the areas of the trapeziums are under the curve. And there is a gap. I'll put it over here, is a gap between the tops of the trapeziums, and the curve. Y equals 4 square root x. There we go. So I think that's clear enough. So part 2, and then find this exactly then. So part 3. Here the integral of 4 root x is 4x to the half between 1 and 9 is equal to raise the power by 1 divide by that number. And that's to be evaluated between 1 and 9. So that's equal to then. Basically the 2 swings up to be with the 4 to make 8/3. So it's equal to top value, take bottom value. So it'll be 8/3 of 9 to the 3 over 2 minus 8/3 times 1 to the 3 over 2. So what do we get? Well, 9 to the half is 3, and 3 cubed is 27. 27 over 3 is 9, so 9 eighths is 72. Tap it in the calculator if you need to, and this is minus 8/3. So this is 216 minus, that's 216, isn't it? Thirds minus 8/3, which is, or this is 2 2/3, so it's going to be 69 and 1/3. If you take away 3, you get 69, add 1/3. So again, tap it in the calculator if you need to. So I is equal to 69 and 1/3. Let's just check the question, find it exactly. Yeah, that's fine.